it's a highly specialized set of information, a unique tech stack that has largely been a set of niche users that we believe, is eventually going to be adopted across every major industry.
Dives into one of the most important shifts happening in tech, and it's happening quietly outside the usual buzzwords. We're talking about the future of geospatial, venture capital, and how the world around us is being mapped, measured, and transformed in ways most people never see coming.
Space-based technology and geospatial data had real value and could be done in sort of a modern venture financing way, raising 10, 20, 50 million dollars.
Joining me is Justus Killian, a partner at Space Capital, a venture capital firm deeply rooted in space tech and geospatial innovation. This isn't just talk about satellites, this is about movement shaping defense, agriculture, insurance, and every major industry on Earth. We'll break down how billion-dollar companies like SpaceX, Rocket Lab, and Planet Labs grew out of one simple idea: that the real value of space isn't getting there, it's the data you bring back.
The reason, you launch rockets and build satellites is really fundamentally about collecting information.
And finally, we'll explore why AI, LLMs, and massive satellite datasets are crashing into each other right now, and why the next wave of breakthroughs might come from those who understand location, not just language.
With these very broad models, you're going to have real limitations.
But just when you think you know where it's all headed, Justice drops something that will change the way you think about satellite data, AI models, and the entire future of how we understand Earth.
It doesn't feel like they're what I've seen as today as like a fundamental breakthrough, and I'm a little bit hesitant to say that.
The future is spatial, so let's get into it. All right, Justice, welcome, and yeah, thanks for being here. I'm excited to hear a little bit about a lot of different topics, actually. But as one of the few venture capital firms solely focused on geospatial, Earth observation, all these different things, I think you can bring a really unique perspective into how the industry is changing. But tell me a little bit about how space capital came to be, and kind of your path to investing in some of these really influential companies in the space.
Awesome, Matt. Well, thanks so much for having me on. It's a pleasure to be here and speak with your audience. Just sort of out of the gate, I want to, say thank you for all the incredible work you do. I mean, I think you're educating a whole generation of folks to better understand and utilize, modern technology to be able to leverage and build geospatial. And so that's directly relevant to our world, which, we're hoping that more people understand and can utilize and benefit from this capability. So I'm excited to be here. In terms of, our firm and, why we focus on geospatial technologies. So Space Capital has been around since 2012. My partner, Chad Anderson stood up the firm. And, you know, we started looking at the reason, you launch rockets and build satellites is really fundamentally about collecting information and providing that information to governments and businesses and consumers here on Earth to make better decisions and navigate the world and so on and so forth. And some of our early investments helped us see how that was possible. The reason you build these rockets, the reason you build these satellites. So that included companies like SpaceX and Rocket Lab and Planet Labs, in their early days. And that gave us a strong sort of investment track record to sort of build and grow a firm around. So from that foundation, Chad was looking to bring on partners that had deep knowledge and deep expertise in certain areas. And so um, Tom Ingersoll was one of the partners that he ended up bringing on and joining the firm. So Tom has an incredible background, but most directly applicable to the geospatial world. He helped lead and scale and sell a company called Skybox Imaging, which was acquired by Google for $500 million, and sort of was a critical proof point, for the venture ecosystem that space-based technology and geospatial data had real value and could be done in sort of a modern venture financing way, raising 10, 20, 50 million dollars and returning a large multiple on that. And so, Tom sort of stepping back and thinking what was next, he wanted to work with a whole new generation of founders that could he could share his lessons learned and help try to be a filtering mechanism, because he knew that there would be a wave of new companies sort of following on after this initial success proof point. So space capital really, I like to say, it was born out of that skybox acquisition. And the root and the DNA of our firm is deeply connected to that geospatial world, and really the intersection between the space and the tech ecosystem. um, so that's sort of the origin story, the background. Now to your question about why a dedicated focus on geospatial technology. Well, the way that we look at it, it really is trying to understand um, how you can. So the origin of our thesis really looks at the adoption curve of GPS technology, positioning, and sort of the modern mapping ecosystem. And we go back to the early days of GPS, and it really was primarily a tool for military capabilities. But in the 90s, through a number of commercial initiatives and regulatory changes, that signal became much more widely available. Low cost chipsets in our smartphone made GPS receivers abundantly available. And you saw the rise of really interesting companies built on the back of location based services that could deliver you a taxi, or help you understand where your food's at, and do some really interesting things. And so um, applying those lessons around how you take a very niche set of technology and scale it literally globally, across many different industries, is the foundation about how we look and think about geospatial technology. And so we've written extensively on this topic. We have a playbook that we put together probably 4 or 5 years ago called the GeoEnt Playbook, and it looks at some of the major sort of transition and evolution, and things that are taking shape. But um, at the core of it, I would say it's a highly specialized set of information, a unique tech stack that has largely been a set of niche users. And through sort of modern cloud architecture and more open source tooling, is increasing the adoption to a much wider audience and a much wider set of users that we believe is eventually going to be adopted across every major industry to help automate and improve a lot of their operations. So that's the sort of who we are, and why we do what we do.
Yeah. And one thing I did want to break down is as a VC firm, venture capital, I from my understanding of the world, many have some central thesis, right? They have some belief about the world, about things changing in it, be it technology or anything that you're investing in. And I mean, you explained that one very clearly around this growth from the 90s all the way to today about location, GPS devices, so on and so forth. Um, why why do you need a specific thesis around geospatial? Like, what makes that unique? And how does that play for other venture capital firms that are kind of playing in the geospatial space that may have a different thesis about some other area of technology? What helps you kind of be unique and stand out in that space to focus on geospatial companies?
So I think that there's a deep understanding at like the sensor level that's required to understand what am I collecting, how am I collecting this information, um, how is this information processed, structured, utilized, integrated into workflows? And then what are the variety of customer segments that are out there that could actually benefit from this? And with satellite imagery and all different types of vector data that's existed in various forms, that's been a lot of this has been widely available through free public means, but very fragmented, both on the data collection side and on the user side. And so um, there is uh, a deep understanding that's required to be able to help understand all these pieces, how they fit together, where value might actually be built, where there's roadblocks to scaling technology, and ultimately where you want to place a bet. And so somebody who's new coming into this ecosystem, maybe just from more traditional cloud or something like that, I think they'll see a lot of parallels, but there's a lot of nuance that you could get tied up on, or sort of blocked, or may not see sort of the forest from the trees without that like history and sort of deep background and network to understand it, because it is a completely separate sort of ecosystem, community, user base, relative to a lot of other sort of modern data science.
Yeah. I I think that shows in a lot of different ways. One that's been interesting for me to see is, you know, and just taking a comparison that I've heard before of like, a trendy topic, edge computing, right? Edge computing on the earth, in terms of a number of different things means something very different than some of the way we might talk about edge computing being processing data on the satellite before it gets to the planet. And the pure compute needed, like, there's not much processing power on a satellite when you need to do, maybe some machine learning or something that you're trying to process data, versus edge computing where you might have a lot more processing power here on the earth. And I think that's like one little edge case that, you know I've seen and heard from people before, but that applies across nearly everything you could start to apply it to. But what are some other cases that you see where it's like, hey, this is very unique to a problem that we have in geospatial, be it with Earth observation or other technologies, that's like you've been able to kind of see that and then build upon it.
Sure. Yeah. I mean, so the I guess it goes all the way back to sort of the origin of the firm with Skyvax and their SkySats. Um, the ability to pack a smaller optical payload into sort of a small satellite, put that on a satellite bus, and actually generate high quality, high resolution images that are commercially viable. Is incredibly difficult to do. So deep engineering was required, for a long part of sort of planet's history. The doves that they built were exciting, interesting. They definitely did image the Earth pretty frequently, on a daily basis. But uh, ultimately, Planet ended up acquiring the SkySats from Google, and even a decade on, those satellites have been a key driver of what they commercially sell and a key driver of their revenue. And so, like, that engineering and sort of technological breakthrough all the way at sort of the physics level, is an area that's been important. That I think only gets, more complicated when you get into these alternative types of data, whether it be um, uh, SAR or hyperspectral, multispectral. You start to get down to, the very nuances of like the things that you're trying to measure, and then tuning the instrument to be able to detect and verify those opportunities, not to mention the user base, the people that can actually work with that sort of hyper spectral data cube becomes increasingly smaller. Like, I compare the work with optical data as sort of like being able to do algebra. Quite a
Mhm.
few people can do that, whether it be earth imagery or all the way down to your smartphone, the ability to use optical data there. When you get into these like hyperspectral data cubes, it's kind of like differential equations. It's just a much smaller portion of the
Mhm.
people that are going to have that technical chops to be able to operate on it. And so, um, yeah, I think, that deep understanding of the physics and how that connects to the end user is where I think we've been, most effective in sort of like figuring out and having some breakthroughs. And I think what that has meant for us is the way we invest is looking at companies that tend to have specialization and actually really deeply understand a customer segment or a use case, as opposed to building a general purpose platform. So, a good example would be a company called Arbol that does parametric insurance, and they use a whole variety of different, data sets to quantify what's happening from the wind to weather, and pay out insurance on top of that. Versus, a Descartes Labs, which would create sort of an analytics layer that could generally be used by many, many different industries, and it's incredibly hard to understand the nuances of each customer pain point, um, when you're trying to like get very deep into their workflows and ultimately provide them insights, to many different industries. So that's sort of how we've evolved our thinking to go very deep as opposed to go very broad.
Yeah. Yeah. There's a number of different things, I mean, that you can do with geospatial data. And that's really one of the best things, and also, I don't want to say the worst things, but maybe challenging things,
Yeah.
is that there are so many different applications. I mean, you go on any geospatial platform or website, or you look up use cases for satellite imagery, or vector data, or anything like that. It can be anywhere. At the same time, things in geospatial kind of remain in their own corner. It's like, of course, everyone knows the term spatial is special, but I think that that's something that increasingly, I think, is starting to change. And I know that story from like having worked with data folks that are non-geospatial folks, and similarly people that want to integrate climate data but aren't working with czar or sar, or I mean, you can list the formats or things like that on a daily basis. So how does that apply to you on, when you're looking at companies and things like that, but also collaborating with other VC firms, that may not play in the space? How do you kind of see the venture capital landscape for folks that are kind of coming in and looking at this from maybe a different investing perspective, or a different technology perspective?
Yeah. Um, it's a great question. We've been quite vocal about the value that we see in geospatial data. Um, we've published a lot of research around uh, sort of the unique tech stack that is built from the hardware, the infrastructure layer, to the processing and tooling, to the end applications, to try to help people see how some of the pieces fit together. Um, we've built a portfolio where um, the folks that are creating the data, providing the data, then work with the processors, the marketplaces, the tooling providers, um, and we can go to them and sort of ask for their insight. And if there is a natural alignment and value does accrue there, that gives us a really positive signal about how and where to invest. And then we continue to follow that down to the end customers, the end users. And so, being an early investor in Planet, we're able to see that, defense and agriculture are some very big, customers, consistent customers. Insurance is another one. And so, by putting out a perspective, it forces us to talk to other really smart people in the industry, get their feedback, see what they're doing. It opens us up to also be challenged and our view to be scrutinized, which allows us to, sort of evolve our thinking over time. Um, and through that process, uh, we've had a lot of investors that are starting to dip their toe in the water, or intersecting with geospatial technologies. Like when they're researching the topic, we come up. And
Mhm.
so it becomes a natural sort of feedback mechanism, in that, hey, we're looking at this interesting company. We read your research. We'd love to talk to you and go deeper. And, maybe we could be a helpful partner in that specific transaction, or maybe we could share some insight around challenges that we've seen in the past that hopefully could be practical for future companies. Um, uh, and so that's I think been the way in which we've approached it. Um, I do think we're at a unique inflection point where many more companies, the complexity, that has been required to transform, various types of vector and raster data, are becoming much more abstracted away. And there's an opportunity for a less sophisticated user base, potentially through AI tools and multimodal models and specialized geospatial models, that could accelerate some of the adoption. And the hope is that just a general data scientist with Python experience could get to a point where they're able to integrate, these embeddings into their workflows, and it, is helping improve their predictive capabilities, analytics, in many different industries. And so I think it's a really interesting and exciting time. The recent announcement with Planet and Anthropic, trying to bring that large data set into sort of their language-based, universe, I think will be really interesting. But all the big players are doing it. Google, is doing some stuff with, a sort of Project X program called Bellwether. IBM and NASA have been doing something. A lot of this stuff has so far been trained on satellite imagery, and I think that there's some challenges there. That broad swath perspective versus a much more specialized view.
Yeah.
But there is a movement to bringing location intelligence into these modern models that are driving a lot of our understanding.
Yeah. Well, it's a good segue, I think, to tackle some of these, big trends in venture capital investing. Obviously, a big one being the umbrella of AI, but specifically large language models. And I mean, you kind of summed it up nicely is that, I mean, I know geospatial is kind of the bubble I live within, but then all of a sudden, LLMs start popping up everywhere. It becomes the technology to know to integrate with. So you spend I had to spend a lot of time getting up to speed on what this stuff does, vector embeddings, like what, if anyone in GIS or geospatial heard that term, they're probably thinking something much different than what a vector embedding is to an AI engineer. But, just figuring out what that is and how to bring data to a LLM and have it interact with it or enrich it or provide it more information. That's something I've been playing around with quite a bit is like, how can I take, you know, data that I care about or am analyzing and give it to someone just to ask a question about. And that's been fun to learn a lot more about. But of course, all the data processes to get that there is a day for a different topic. But let's talk about that a little bit for this AI LLM big shift. Obviously, a lot of venture capital interest, funding, development has been taking place around this. How do you see this new shift in AI changing geospatial or geospatial coming to it to meet the challenge that's presented today?
Well, I think, the first wave that we saw was models being built based on purely text-based capabilities. Pretty quickly then you got these multimodal models that are trying to bring in all different types of data, very general purpose in nature. All the experts that I've talked to have said that, with these like very broad models, you're going to have real limitations in terms of the depth of knowledge and the ability to go super deep in terms of unique data structures and what that can mean. And so I do think location is probably one of the single biggest, gaps in what these multimodal models are able to do today. And I think there have been a handful of interesting examples where you've seen like satellite imagery being able to be dropped into like chat gpt, and you get some like very basic sort of object detection and understanding. Um, but you know, I think that there's a lot of like limitations into what it can do beyond that. And so like just even trying to ask for like directions in some of these LLMs, like it can't even give you sort of basic understanding of how the pieces fit together. So um, what we've seen is, then a series of specialized models that are trying to go quite deep, mostly starting with satellite data. And I'm not sure that that's necessarily the best way to do it, but you have Clay, you have IBM and NASA. There is, like I mentioned, some of the stuff that Google's doing. Um, you know, I haven't had the chance to sort of like play around too deeply with this, but the what I've heard and the sense that I've got back is, it's interesting. It's better at, it has a lot of similar feels to, 2016, 2017, where we had these big general purpose geospatial platforms, and the idea that, you could quickly structure data and solve, get to like insights very, very quickly in a wide variety of ways. So like car counting on steroids, the ability to like extrapolate from, some forest or some, quick location and replicate that at a global scale. Um, it doesn't feel like they're what I've seen as today as like a fundamental like breakthrough, and I'm a little bit hesitant to say that there's a major shift there. But the ability to bring some sort of structured understanding of location into these models, I think, is going to be really, really important. I mean, if you've been looking at it, I'd love to hear your sort of take on this because it is pretty wide open right now.
Yeah. I do have ideas. And I think one is, I mean, like you mentioned, some of the we'll call them general purpose models. But I mean, I think it's if you think of like where GPT-3 was, it was good. You could certainly do things with it, but looking at where it is today,
Yeah.
way different. And I think we're kind of in that moment where we're seeing interesting stuff for these general purpose questions that can be asked, right? And you can do it on relatively small scale, like count the cars in this image, or detect water bodies, or do some of the stuff that like you said, rewind 7 8 years. Deep learning was like it was a whole big thing that was it was what you could do was amazing, but just the process to get that up and running was very difficult. So that's one big one that's interesting to me is the ability to take, well, what LLMs do really well is they take large amounts of information and allow you to produce something new. The downsampling of very non-granular weather data to very granular is potentially really interesting. And I think I've
Mhm.
seen some of those models from IBM, NASA, where you're taking this weather data that's at 10 kilometers and sampling down into meter scale. That's really interesting, and I think that gives you a better, more accurate data set, but also something in real time with more accuracy because that data is being continuously collected. Now, what I think is probably the most interesting, phase of all of this is meeting the LLMs with what they do best, which is text, right? That's what they do really well. And LLMs today have some spatial awareness in terms of, if I tell it what the East Village of New York City is, it will kind of know. It can spit out some ideas of it's bound by these streets based on Wikipedia entries or websites it scraped and stuff like that. Can it perform spatial analysis? No, it cannot. So, what I think is probably the two pieces that need to happen there are really good data engineering, being able to consistently provide data that a large language model would want in a text-based form. So an example of this I've been working on is understanding river flooding, right? Pretty simple use case that traditionally is delivered by a map, right? You're looking at a map, you see where there's rivers that have higher or lower water. That's great, and I can see that visually. But what if I was to wanted to ask an LLM, "Hey, where are rivers flooding today, and where are they going to change?" It's not going to know for the first thing about that. You have to provide it the data, and either that's going directly into the model, or you're putting that alongside it with the vector database. And that requires the data engineering to keep that data fresh and up to date, and then providing with text. And it's going to know where Lubbock, Texas is related to, Dallas, and it can do some of those basic questions. So if you think about it, it's just a new delivery format for what, you know, your GIS web maps were intended to do, which was deliver data to a lot of people. And I think
Yeah.
that's where we're going to see that. So it's a combination of those things that I think is really the end state I'd like to see is that, and I think where LLMs want to go is become this information kind of portal where people can ask questions, get structured responses, but we have to bring the location data to that, and that's going to be met with the form of good text data, and be that weather, be that whatever, whatever that is. I think that's probably the two things I see the most is these models that help us make our current data better, and then of course applying and getting more specific with the models, right? The general purpose models will improve and we can do more of the specific things we want to do, and I think that'll keep going. And then just getting more location context to LLMs, which is kind of the leader right now. And I think that's probably the most interesting thing that I'd like to see is who's, how are you going to create good data engineering practices to feed in all the questions about the earth people want to ask.
Yeah, I think that that makes a lot of sense. The ability to accelerate some of that, AI ML workflow right now that requires a bunch of people, potentially a model like the clay could help accelerate some of that to get to, more structured data much more quickly. Um, One of the things that I think is interesting but a little bit overlooked is um, the ability. Like, I am a bit skeptical that these, general purpose models can. They're creating relationships around words, right? And so relationships that we may not even know exist and we're never going to be able to like directly observe and identify, but they've uncovered them. That same reality exists in our physical world
Mm,
around how we've built things, why we've built things, where we've built things. The GIS layers that we put are, on top of our maps are codified understanding of those relationships. But I think that there are exponentially more that we don't fully understand or observe. And so the ability to turn loose a model on a lat long to be able to derive location relationships based on like, you know, a meter, 10 meters,
mm,
miles, there's so many layers. It's like an onion of spatial relationships. It does seem to me that there is an opportunity there to really like rethink and sort of reframe how we understand spatial relationships and then how you could potentially access that. And so this is where, there are some companies that are talking about like geo embeddings and being able to just hit an API and get like a very, structured set of information about, a
mm.
specific lat long that, gives you a whole deep understanding of what's there and what's around it and why. And that's pretty cool. That could change how, I think a lot of modern data scientists and predictive pipelines are built and run, and what we understand about our physical world. But still very early innings there.
Yeah,
So,
yeah.
to be determined.
I know. I love that. I've seen some of the different like geo embeddings start to pop up to be able to understand a place, right? And I mean, really, that's what we do is understand place. Um, and my mind always goes to like, how do we get the best data up to that? And like, there's gosh, I was looking at a data set the other day of human change, right, at a 30-meter level for every 5 years back to like 1990 something. Amazing data set. Uh, and it's on Google Drive. How do I get that into, you know, this amazing research that's been done all the way up to someone asking that in a geo embedding or processing it and doing those things. So, I think I think that isn't far off. If I had to say, we're in that like 5-year range where I could maybe even less, given the rate of things developing. But that would be the end goal because that's really what spatial is, understanding information about Earth and place. And I think the goal of why I think a lot of people get into this too is they want to, you know, help get that data into more decision makers' hands, which is, ultimately what we're doing, what you're investing in, and what we're bringing forward. Um, what are some other trends that you're seeing kind of in the space right now, apart from the AI kind of boom that you've been kind of paying attention to?
Yeah, I think you mentioned, edge and moving to autonomy and the ability to, like more quickly get to decisions. So particularly in satellite, the world of satellites, like this is really important. One, there's more satellites up there, so how do you dynamically task and manage them? How do you, pre-vet what's coming down? So, when you're over a ground station and you can download everything, it's only things that you actually want, and you can sort of pre-process and get to a closer, get quicker to decision making capability. So that's certainly, an interesting area. I mean, we've seen that all the way down to a variety of IoT devices, even on like oil wells, the ability to make decisions at the edge. If you're like pumping water out of the ground versus oil, like you should shut that off because it doesn't necessarily make sense. But as opposed to pumping that data to the cloud and then being able to analyze it and then like make a decision, turn it on or turn it off, like, moving even sort of that like low throughput IoT, device intelligence to the edge. It's a more common pattern. Um, I would say that, probably 3 years ago, like, anything around agriculture, insurance, climate, the ability to quantify, measure, track across supply chain, like these, were really important and really interesting, and there was a lot of innovation that was happening here. Um, all of those companies are still doing really important work. Companies like Flood Base that are trying to build, specialized insurance for flood capabilities, or like I mentioned, Arbol that's providing parametric insurance from agriculture to, clean energy on the wind side, to a variety of different other areas. All that stuff is really important. It's sort of been drowned out by um, a change in sort of political climate and shift in geopolitical winds. And so it does seem like, you know, defense tech is, taking more of a priority. So around like alt PNT, you have Maxar that recently came out and talked about, their sort of GPS denied capability, like drone technology that's able to map, based on a base map of their satellite imagery and process at the edge to, navigate in GPS denied environments, command and control platforms that are able to integrate all different types of data into, spatial awareness and automate operations and tasking, and get to more rapid intelligence. Um, Simulation of different types of activity, um, beyond sort of like basic wargaming, but like all of the interdependencies of that, the logistics, the manufacturing, the complexity of that. There's a company in our portfolio called Exia Labs. It's built on sort of a modern gaming architecture to drive simulation in like a 3D photorealistic sense. Um, Looking at, much more complex operations than just the battlefield. Um, those are some of the areas that I think, people are willing and interested to, allocate. But I still think, a large part of the ecosystem and the industry is anchored by that sort of like government spend, and a handful of like big users across agriculture and insurance. And the future, I think, is going to be really dependent upon, more industries, being able to utilize and benefit this data. And it's probably going to look more like structured data that flows into different pipelines than it does like anything on a map, right? And it feels like we're getting closer to that reality. But I don't know. I would love to get your take on, what you see as top trends and customers that are, pulling, geospatial into their workflows.
Yeah. I mean, I think you kind of hit the nail on the head is that the data needs to meet the end consumer. And in a lot of places, that's not going to be a map. That's going to be a data point, an insight, something that's giving a very real time view of what that is. So, an example of that might be a logistics company. You mentioned logistics, and that's still a key one, but just understanding, you know, out of my fleet today, how many are getting impacted by weather,
Yep.
or who's going to be going through blowing snow, and what do they need to take a route change, and what time is that going to add, and in what states. Now, I could see that on a map and an operational dashboard, and that's great. And I've seen many operational dashboards do that. But for many cases, especially if you're in a exec level position and you need to make some decisions quickly, I just need to know the bullet points and the stats and get to it. Um, and that's one use case that can go across any industry, I think. But increasingly, I think, you're seeing a lot of need around climate and changing climate trends that are driving a lot of business decisions. It's very hard to create long-term planning when things are changing quite rapidly. I think another one is, around, shifting events that are taking place. I think, how do we respond to shifting demographic and population trends that were, you know, not what we thought they would be from a few years ago. I mean, COVID was a good example of this, with just a significant shift in people and population moving, and that shifted and changed a lot of what we're doing in under the hood. But how do we start to model that out and then change long range planning that you're starting to do? So I think that those underlying shifts that are taking a place in any part of our society today, people want to get a handle on, and then figure out very quickly what they need to do with that information. And that's going to be different from, I want to create this amazing dashboard or get you anything like that. That you want to get down to the point and have that data up to date on a regular basis, and that's going to take good data analytics that a lot of companies have in place, good data science, but most importantly the data pipelines and the data to consume in a way that meets those consumers, which is kind of the people you need to meet. We have to bring the data to them to make it accessible. And I think a lot of things we talked about today, from creating models that can read this stuff and process raw imagery and get that data into a usable format, all the way through to just creating very readable outputs that are not here's a shapefile and or here's a geotiff and go for it. We have to create that data access, and that's a big thing that I do in my day to day. But um I think it's like one thing that you mentioned that I think was interesting was looking at how do you let's take Planet for example. Planet it maintains this constellation. It's a very different company when you're talking about building satellites, building physical infrastructure that goes into space versus a company like Arbol that's has a industry focus that's taking the data and doing it in a very specific use case. How do you see, and I guess I'm kind of flipping the question back to you a little bit. How do you see the application of creating these, and also how do you invest in such a diverse set of companies from understanding the physics of space to understanding how to apply geospatial data to insurance use cases? I think that's an interesting question to start to break apart, because there's a lot of ways if someone's watching this and trying to say, hey, I have a really big idea for geospatial, where should I apply it? Should I go general, big, broad, or should I go specific and focus on those problems? How do you see those two things and working together? And
So it's an interesting question. Most venture capitalists look at a very broad set of companies and industries and customer segments. So they'll invest in, um, you know, cloud processing, semiconductors, energy generation, SaaS, um, quantum computing, a very, very broad set of things. Typically, what they do is they have, one expert, a PhD or a founder that had operated in an area that comes in and sort of leads the specialization of deal flow in a specific category. Um, you know that's not what we do. We have a specific lane, and we look at geospatial as a tech stack from the infrastructure all the way to the application, and we're able to basically follow the data, the ones and zeros down to where they get utilized. And since we've been doing this for 10 years, and our careers have been, and our partners have been building and selling into these customers for such a long period of time, you know, we know what customers are saying. We're out there like actually across multiple companies selling into them. We're investing in multiple companies that tell us what they need or what their challenges are. So there is a compounding effect that when you are investing at different layers of the tech stack, like there's natural puzzle pieces that fit together, right? We haven't found that general purpose company that can do it all. you know Planet sort of set out to do that. They faced a lot of sort of first mover disadvantages. They were inherently satellite guys. um, you know they built some interesting satellites that worked okay. Then quickly they realized that they needed to bring all this data down, so then they had to build a ground segment. Then quickly they realized they needed to have a processing and an analytics platform, so they had to build a lot of that on-prem and then eventually move that to the cloud. Then they realized they had to build this whole sort of software architecture on top in general purpose. And they realized they had to educate the customer base, so they started hosting these big events and bringing people in house, and you know trying to build like specialized verticals within their platform to go deep into agriculture and logistics. Um, that took a lot of time, a lot of money. It was really hard. I would say it was probably the most valiant attempt to sort of build a full stack. And ultimately, they've pared back, and ultimately they sell to mostly defense and agriculture. Those are sort of their biggest customer segments. And they sort of found a bit of a niche, and that's what they've done. But I think I wandered on your question. You were asking like, how can you do all of these things? And my response was, we don't do that much relative to most. We stay in our lane, and our knowledge sort of compounds. But what did I miss there? I missed some, I think, some important questions.
I think you hit it, and actually, because I can see there's this like there's some conversion point where these two things meet. Like right, where you have a general purpose, either satellite imagery or data provider or something that kind of is collecting lots of information. They're trying to get to the end where it's like to an end consumer on a specific challenge and use case. Whereas some companies are coming from the other end and they say, hey, we know parametric insurance, we know logistics and operations, we know this, and they're bringing it back here from the angle of we know this sector but we're have to meet to the data or connect to the raw data. And I think it's pretty bold to try to go all the way to connect all of them. And and I think there's probably I know there's space in the middle that how can we connect raw data to the insights that people need to serve up here and create more companies here, and also enable more companies to push more data through, right? And I think the more I've looked at our space and tried to be critical of it, I think you know instead of going and trying to build the all-in-one geospatial platform, I think there's a lot of us and a lot of companies that are doing specific things very well, you know, and sometimes it can feel like you need to be the end all be all, or, and I wrote a post about this saying like we don't need to eat each other's lunch. Like, we can each have a little piece of the sector, but how do you collaborate and connect together is going to be through success. And I think that that's a lot of the vision that you have to see day to day is how are these pieces of the puzzle fitting together, and where do you strategically want to sort of invest in and work with these companies. And I know from sitting on the other side of a lot of investors work is connecting dots, and seeing how it fits together. So I think you answered it clearly, is it's having that deep understanding of our space and our world allows you to see how those got dots can connect, can fit together better than some. And I think that's probably the key. So I think yeah, we got there at the end of it. So
Well, thanks for bridging that gap. I
yeah,
think that's the right conclusion. Was there anything else we wanted to go down? I mean, that's a natural place to conclude it. We could
I thought
also
so.
pivot somewhere
Yeah,
else. Yeah.
I think that brought it together nicely. But yeah, yeah. Well, Justice, thank you for taking the time. I'll include information on Space Capital and places for people to get in touch with you. Anything else you wanted to leave us with today?
If you're interested in this ecosystem and sort of how space connects into the different layers of geospatial and the end applications, um, we run a free platform called Space Talent. It highlights a lot of these companies that sit at the intersection of this. There's a lot of jobs that are listed. There's monthly one-on-one networking to be able to meet folks in this ecosystem and talk and build relationships. People found mentors, they found co-founders, they found investment that has come through this. And then I also host weekly office hours to talk to folks that are taking a kernel of an idea and trying to shape it into a potential business model. And I love these conversations. A lot of them more recently have been gravitating towards geospatial, and in some cases it's very specific to the end use case, and trying to find the right data sets to accelerate and scale workflows. Or in some cases it's like, hey, we have this really interesting way to process data, could it be applicable in this area? And so please consider taking a look at spacetalent.org, signing up, and we'd love to be helpful. We're invested in this category for the long term, and so that means we can be very patient. We can invest a lot of time in folks, and I love to learn and I love to support. So please reach out. I'd like to be able to do that.
Awesome. Yeah. Well, I'll make sure to include those, and I know those are great resources. So, thanks for all you do for the space and the community. And I'm looking forward to all the amazing things that are going to come out of the work you guys are putting in. So, thanks for taking the time today. Appreciate it, and I'm sure we'll be talking again soon.